Okay. So you think I'm kidding about the CIA spreading lies? Um, so if you heard the previous live stream talk that I just gave, um, check this out. This is one of the CIA spreading lies. Best way to go would be to find out what particular you want to do and then start researching and drill down into the specifics. For me, one of my first questions way back in the day was, how does the computer even know where to get the OS and start it? Which led me to researching PCI BIOS boot process, incidentally to writing a simple boot sector floppy, which everyone seems to start with for good reason. Okay, I said that I used BIOS 42. That is not PCI. Oh, PC BIOS. He's creating misinformation. Okay, he could be talking to me. Okay. BIOS 1342. I'll tell you the secret that OS Dev tries to hide. Okay, interrupt 13 is the disk, and 42 is for large hard disks. It's 48-bit blocks. Now, how much you want to bet Box, the emulator, doesn't support 42? It's a CIA plot. They're trying to hide this from you. This is a simple, super simple so first he said PC BIOS. Now that's not to be confused. He's trying to confuse it with PCI BIOS. Okay, the PCI BIOS, this is for when you want to access PCI device configuration space. It's a 32-bit BIOS, and it's okay. So first of all, let's go look in my bootloader where I call the BIOS. Okay, so UEFI and BIOS are the two boot mechanisms. The older one is called BIOS, the new one is UEFI. And I use the old one. The way you make an operating system is you tell the hardware people to support it. That's what Microsoft does. What a professional company does is says, you suck my d-. And once I have my space alien recognized, I'm going to tell the CIA to suck my d-. I'm going to tell all the hardware companies to suck my d-. I'm going to say, support God's temple, you. Okay, that's the way you do support. You say, you, make it work. Okay, so TempleOS will run in VMware. It probably will not run, it won't run natively anymore. Stay tuned because I'm going to tell them to suck my d-. And anyway, so the BIOS piece, the BIOS is 16-bit code, and bootloaders run in 16-bit, and my bootloaders call interrupt 1342. That's the secret they're trying to hide. They're trying to hide that. They tell you to use sector head cylinder. That's ancient, and it's hard. It's hard for someone who doesn't know assembly language. For me, it's no big deal. I did start with that, but what you need to start with is interrupt 42, interrupt 13, number 42. So, as a matter of fact, on a modern hard, there's CHS, LBA 28, and LBA 48. CHS was the first PCs. Those are really tiny. Then they made LBA 28, and then they made LBA 48. And at OS Dev they'll tell you, oh well, you want to support the old systems. Why the would you support 28-bit or CHS, for God's sake? Oh, that you got way too much. It's hard enough keeping up with modern technology. Why would you support a 386? That's just they're sabotaging you. They're making a bunch of crappy code in your operating system. Just do 48. That's like the transition from 28-bit is like 128 gig. All hard disks are bigger than 128 gig. So trust me, the BIOS will in fact support 48. Does Box support 48? How much you want to bet Box does not support 48? That's the kind of shit they sabotage you with. That would be evil. Anyway, so PC BIOS, he's spreading confusion. They try to spread as much confusion as possible. Once you change modes to protected and then long mode, you can't use the BIOS. And in fact, you need to write your own driver. My operating system is pretty much guaranteed to work in VMware or QEMU, and it's pretty much guaranteed not to work natively. In the future, I'm going to say suck my and the companies are going to support it because of God. And anyway, so these evil, he's confusing PCI. Don't say PC BIOS. That's maybe he's trying to. Anyway, what you do for a native disk driver is for a native disk driver, I don't use the PCI interface. What I do is I use I/O ports, and this is my 48-bit select block. You write 1, 2, 3, 4, 5, 6 bytes for the block. So this is the driver for the hard disk. You can look at this code. You can use this code. It's the port I/O. It's the simplest way to do it. It doesn't work natively anymore. It only works in VMware. But the good news is it has, my operating system has, I would bet 100% working in VMware. And in the future, I'm going to do all my I/O with I/O instructions, not the PCI memory space, memory mapped registers. We're going to do it. We're going to make it work because it's God. Anyway, so what is the wicked CIA up to today? For me, after I wanted to know how to draw stuff, floppy. They tell you to use floppy. Well, floppy is wicked. There's gaps, and I in fact did start with floppy, and I did use Linux code, but now I have a hard drive driver and no Linux code. I don't know if you want to do floppy. I tell you how to. I have a video on making an operating system. What I do is go to my website, YouTube videos, making an operating system from scratch. And what this will do is my operating system gives you total access and freedom to everything. So if you want to write to your boot sector, my operating system lets you write to your boot sector. And so you can just install a boot sector from, you can launch your operating system from my operating system. I used FreeDOS to launch my operating system, but now they made FreeDOS virtual x86. FreeDOS used to run in real mode, and that allowed you to change to protected and long mode. The CIA was not happy about that. They're trying to f you up as much as possible. They want you to use floppies, CHS. They're trying to make it absolute. That's a bunch of wasted work. They want you to get your jollies out of some stupid stuff that's not threatening anybody. So floppies are wicked. You don't want to do a driver for a floppy. And since then, it's just been more of the same. Figured out what I want to accomplish, do research, integrate my knowledge into existing blah, blah, blah. God, I have no patience for blithering idiots. Okay, so PC BIOS. So in order to do, okay, so let me tell you some information about doing a hard drive driver. So first thing you need to know is ATA is the specification, and everything you need to know. You have commands like identify that there's a ATA is the lowest layer, and then to access a CD DVD they call it ATA packet, ATA PI, a TAPI. So a TAPI is the CD DVD. So this tells you how to do a ATA command. You can look at my code that I just showed you, and it's a driver for ATA, a TAPI, and it's done through I/O ports. Now, the original ATA spec had like 9 registers, IDE, ATA. Okay, they had standard ports for the floppy and the what is it, 3 F6 3, I don't know. So the standard, they used to put now you access hardware through I/O ports. Now you do it with PCI, but the original, the CPU is designed for hardware through I/O ports, and now they're not using the CPU properly. They're doing everything through PCI. So the first thing you have to do is find out which ports are used for the hard disk. So there's a Linux command called ls PCI -v, And in here you will see something called SATA. This is serial ATA, and this has some port numbers. Now on the computer I had about 3 years ago, you could use these you could look up these port numbers and then enter them into my program. You know, when you compile the kernel, it asks you for port numbers. Well, if you have an older machine, not too old, if you have a 64-bit machine from the time period 2003 to 2010, you might be able to enter SATA port numbers and get it to work natively. But after about 2010, it's pretty much hopeless. But it's going to be Return of the King when we tell them to suck my because it's God's temple. So anyway, so the first step you have to do is identify where the hard disk is, identify what ports, and in the original design there was primary IDE, secondary IDE. 1F0 was the port number, 3F6, 170. Then they started moving them around, and in this example the ports are F070, F050. So there's 8 ports and then 1 port. There's a total of like 9 ports. And so there's 2 numbers. The first number is the block of 8 ports. The second number is the block of 1 port. So you need to enter both those numbers. If you're doing CD-ROM, I think you don't need both ports. Anyway, you don't in my system. I'm not sure if that's always going to work. Anyway, so a clue is the first one has to be 8 ports. So that means you can rule out, basically you have to try all combinations to get it to work. And it has to be at least 8 for the first one. So now when you compile the kernel, I used to I have my own configuration files for when I compile my own kernel, and I enter on a real machine. I have it rigged so that I can recompile the kernel really fast. I have basically you can specify standard in and then answer all these questions automatically, and so you can recompile really fast. So one of the questions is the I/O port, and you need to look at ls PCI -v, get the I/O port. So the PCI BIOS is, sometimes you can use it to find out these ports automatically. So in the if you get a spec on you have your CPU chip, and then you have auxiliary chips, and the USB is documented in this chip, IDE controller. So these are PCI devices. They have some, there's 3 memory spaces that I know about. There's your main memory, RAM and ROM, and your main memory space. There's the I/O port space, which is 64K, and those used to be all you had. Then they started making the PCI devices, and there's PCI config space, and that's a magical place that you get to with your PCI BIOS. And then, well, finally, the PCI devices map registers into ordinary. There's your main memory space, there's the I/O port space, there's a config space, and the PCI devices start using main memory space. Anyway, it's just never mind about that. There's a 14 primary command base address. This is the I/O port. You remember when we did this, the LSPCI, when it said SATA ports? This will tell you a SATA port, this will tell you a SATA port, this will tell you a SATA port, this will tell you a SATA port. So these are the I/O ports. This is going to be something like F010. That's where you get the F010. I looked it up on Linux, but let's say you didn't have Linux and you needed it, then you're supposed to be able to use the PCI BIOS to figure that out. But God help you, because, well, the PCI BIOS has okay, so I showed you the config space. You have to identify what device it is, and the PCI BIOS is supposed to work for different device classes. PCI device classes. So you're supposed to tell it, I'm looking for a hard disk. Give me the config space value 14. So with the PCI BIOS, you tell it a device class, mass storage device, ATA, so you have to check all of these, IDE, ATA, SATA, and it's worse. There's like subclasses, and it's all up. So I support the PCI BIOS, but I really don't use it for anything. I just wanted to give you a head start if you want to play with PCI devices. So PCI rep, this will tell you the device codes. PCI devices have what do they have? Device. There's bus device function. So they can have multiple buses. That's normal. That's kind of weird. Then they have device category, device, and then function. And each of those ICH chips puts them in slightly different places. So you have to use PCI BIOS to look up the devices. It's really up. We're going to fix it, make them suck, because they it up on purpose. If you only knew how much simpler USB could be. They don't even let you do a generic serial port connection. It has to be a registered device. We're going to fix all that. We're going to tell them to suck, because God. That's why. Because God. That's why.